All right, so in this video, we're going to look at these 10 identity proofs. And so I'm going to run through all 10 of these examples. If you don't want to write them down feverishly, there is a link to this in the video description. So there's a link to this PDF. You can download that. And I'm going to just kind of walk through each example and tell you how I do it. I might go down a couple dead ends and have to start over just to kind of show you how that works, and that's okay, but I'll kind of talk you through how I solve these trig identities. And once again, it's okay to make mistakes. We learn from our mistakes. You know, don't expect to get all of these right on your first attempt. If you do, then obviously you're doing really well. But if you don't, you don't get discouraged. It's okay. You don't always see everything the first time around. All right, so this is going to be a little bit long-winded. Feel free to skip ahead to ones that you want me to show you. So if you know how to do 1, 2, and 3, just skip to 4. But it's going to go through all 10 of these examples on this video. Okay, without further ado, I have a second one for myself just so I have a little bit extra room. So let's zoom in on number 1, and let's see if we can figure out how to prove that 1 over cosine squared theta minus 1 over cotangent squared theta is indeed 1. So there's a couple different ways you can go. One way is to turn everything into sine and cosine. The first thing's already cosine squared. The second thing, 1 over cotangent squared, we could turn into 1 over, we could use like this identity and have it be 1 over cosine squared over sine squared. But I feel like that's just going to make it a little bit messier. The thing that is really kind of a telling sign on this one is this 1 right here. That 1 tells me, hey, we're probably going to, and there's all these squareds here. So we're probably going to be working down in this Pythagorean identities area. So what I'm going to do is I'm going to change both of the things on the left using the stuff up above, and then see if it turns into some Pythagorean identity. So probably one of these reciprocal identities is where we're going to start. Okay, 1 over cosine squared is going to be this first reciprocal identity. So 1 over cosine is secant, so 1 over cosine squared is secant squared. And then 1 over cotangent squared, well, this, if we rewrite this, this would be tangent of theta equals 1 over cotangent of theta. Those are reciprocals of one another. So that means 1 over cotangent squared is tangent squared of theta. So our first step was changing both of those fractions into non-fractions. And then I see some stuff here that are squared and subtracted, and I want to look down at my identity sheet. Let's say, is that one of those Pythagorean identities? And look at this right here. 1 is secant squared minus tangent squared. How cool is that? So that's just 1. We can just write that as 1. 1 equals 1. Boom. We're done. Sweet. All right, cool. So let's erase this stuff. We'll move on to number 2. Probably could have left that for later in case we needed it. But, you know, number 1's in the books. All right, so let's slide over to number 2 and see what this one says. All right, this one says cosine squared of A times secant squared A minus 1 equals sine squared A. All right, so this is screaming distribute me. I don't know if you guys see that or not. I want to switch up from pink. Let's do blue here. So this is really saying, hey, distribute me in. But you might have also noticed, one thing I'm also seeing over here, secant squared minus 1 is tangent squared. So you could just change that to tangent squared. I think either way you do it, you're going to get, you know, down an okay path. So this one, it looks like there's probably 2 okay starting paths. I'm going to distribute because that's what I saw first, and we'll see if that takes me down a dead end. So when I distribute this, I get cosine squared A times secant squared, oops, I forgot the C, secant squared A minus cosine squared A times 1, which is cosine squared A. So I'm working with the left side here. And let's see, I just made it messier. I want to end up with sine squared A at the end. So let's see if I can do something with these two things here. Cosine squared A times secant squared A. I'm just going to rewrite this. Cosine squared A times, but secant is 1 over cosine. So this would be 1 over cosine squared A. Okay, so I just changed secant squared A into 1 over cosine squared A. Well, this stuff here, when I multiply these two fractions, it's really over 1 there, we get cosine squared A over cosine squared A minus cosine squared A. Well, cosine squared A over cosine squared A is 1 minus cosine squared A. And guess what 1 minus cosine squared A is? I think I see that right over here. I use theta on my trig identities sheet, but it works for any angle, theta, A, x, whatever you want to use. So that would be sine squared. So sine squared A equals sine squared A. That's what we wanted to get to. So we're done. Number 2 in the books. All right, once again, let's get rid of our marks over here so we can be ready for number 3. Excuse me. Zoom out, scroll down to number 3. All right, so I need to change this big messy fraction, secant squared x minus tangent squared x, all of that over secant x into just cosine x. So if you understand graphing, what's kind of cool is if you type all of this into your graphing calculator or into Desmos, whatever you use, it's going to start up here at 1. At 90 degrees or pi over 2, it's going to go to the midline, and then at 180, it's going to be here. It's going to look just like cosine, which will be pretty cool. This whole messy thing, if it is indeed true, which it is going to look just like cosine. So let's figure out how this works. That top is screaming, hey, look down here at these Pythagorean identities somewhere. Where do we see secant squared x minus tangent squared x? Well, we used this on number 1, didn't we? Secant squared theta minus tangent squared theta is 1. So I can replace that whole numerator with just a 1. Because that is just equal to 1. So this turns into 1 over secant of x. Well, we know that secant and cosine are reciprocals of one another. So if we have 1 over secant of x, then that means that's the same as cosine of x. And look at that. Cosine x equals cosine x. That was pretty quick. It was just a 2-step proof. Not too bad. All right, number 3 in the books. Let's get rid of this stuff so we can work on number 4. This one says sine b tangent b plus cosine b will all simplify down to just secant b. Okay, well, I'm not seeing any squared, so right now I'm not even going to worry about the Pythagorean identities at the bottom. I'm just going to worry about the reciprocal and maybe, this top 5, the yellow and green identities up above. Okay, well, sine is just sine. I'm not going to switch that to 1 over cosecant. That's not going to help me. But tangent I can break down into sine over cosine. So let's do that. This is sine b times tangent is sine theta over cosine theta. So this would be, in this case, sine b over cosine b plus cosine b. And we want to prove that that eventually will give us secant of b. All right, this first stuff multiplied together, sine times sine is sine squared. So we've got sine squared b over cosine b plus cosine b. Well, if I want to add fractions, I have to get a common denominator. And so I'm going to do this in another color. Since this is over 1, I'm going to multiply by cosine b on top and on bottom. Go back to blue here. So when we do that, I've got sine squared b over cosine b plus cosine times cosine is cosine squared b over cosine b. And I can combine these fractions now because they have a common denominator. Keep forgetting my equal signs there to show my next step. So this ends up being sine squared b plus cosine squared b all over cosine b. All right, so it's still pretty messy. We need to get this down to just secant. But in my previous videos, I talked about you need to know this one by heart. Whenever you see sine squared plus cosine squared, that should scream, change me to 1. So if I scroll down here, I can change the top of that fraction to just 1. And what's 1 over cosine? Well, it's secant, and that's what we want to get to. So this just turns into secant of b. Secant b equals what we're looking for, secant of b. So that one was not a two-stepper. That one took multiple steps, but we eventually got there. All right. What was that one? Was that number 4? Scroll to the next one. We'll clean this off like we've been doing. Let's see. We'll zoom out here. Yeah, number 4. So let's slide over to number 5. And we'll zoom in a little bit. All right. Well, I've got sine x times cosine x on top. And then I've got 1 minus cosine squared x on bottom. And I eventually want to get that just to be cotangent x. All of that should simplify down to cotangent x. All right. Well, the bottom kind of screams Pythagorean. It's got a 1 and a cosine squared. So is that anywhere over here on the right on my trig identities? It sure is. Look at that. We've got sine squared is 1 minus cosine squared. So I can change that bottom. So what I'm going to do is just write the top. I'm not going to do anything with the top right now. And then the bottom, that is sine squared. All right. This next step we could probably do without writing out what I'm about to write out, but I'll just explain why this works. So this is sine x cosine x on top. And then sine squared x on bottom, we've talked about, is sine x times sine x. Sine squared is sine times sine. So if we have sine x over sine x, and we can cross those out because everything is multiplied on top and everything's multiplied on bottom. If there was an adding or subtracting in there, you could not cancel those out. So because everything's multiplied on top and bottom, that's a legal step. So the signs cancel out. That's just 1. Sine of x over sine of x is just 1. So then we end up with cosine of x over sine of x. Let's say cosine. And what is cosine of x over sine of x? Well, it's right there. Cosine theta over sine theta is cotangent theta. So this is cotangent x. And that's what we're looking for, right? Cotangent x. Look at that. Sweet. Cool. All right. Number 5's in the books. Let's look at number 6. We're halfway there. Great job. I don't know why I'm telling myself that. All right. Number 6. Oofda. This one looks a little messy. All right. We've got cotangent squared a plus cosine squared a plus sine squared a equals cosecant squared a. So we're adding all these squareds up, and we're going to end up with cosecant squared a. So maybe what I'd encourage you to do, if you've just been watching me and not trying them yet, is I would pause this one, look closely at it, think about it, and see if you can figure it out. This is actually a two-stepper, if you see it. Hopefully you pause it, And hopefully you saw what I saw, that we have cosine squared A plus sine squared A. And that is right there. Cosine squared plus sine squared is 1. So we've got cotangent A plus 1 equals cosecant squared A. Well, let me be consistent with what I've been doing. I'll get rid of that. And cotangent squared A plus 1 is on here somewhere. It's right there. Look at that. 1 plus cotangent squared, that's the same as cotangent squared A plus 1. It's commutative. So this is cosecant squared A. And that's what we're looking for. Cosecant squared A. So it looks super messy at the beginning. There's really a two-step proof. Not too bad. All right, we're done with number 6. Let's look at number 7. Oops, went to hit the erase button. Number 7. Ooh, a little messy here. So we've got 1 over 1 plus tangent squared plus 1 over 1 plus cotangent squared equals 1. I see some Pythagorean identities here, I think. Let's start with this first one, 1 plus tangent squared. Is that over here on the right somewhere? Yep, it is right there. What about 1 plus cotangent squared? Is that somewhere? Sure, it's right next to it. So I can change both of those denominators into what it says over on the right. So we've got 1 over 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. So it'd be 1 over cosecant squared theta. Well, we know that secant is the reciprocal of cosine. So this ends up being cosine squared theta. And cosecant is the reciprocal of sine. Think about that for a second. And cosine squared plus sine squared is just 1. That's right there. So we wanted to get down to 1, and we got down to 1. Beautiful. All right, 7 down, 3 to go. Let's get rid of these pink marks over here on the trig identities. And let's look at number 8. All right, cosecant A minus cosine A cotangent A, and all of that should simplify down to sine of A. So as we've done a bunch of these, I've kind of talked my way through them. And whenever I see squares, I'm assuming we're looking at one of the Pythagorean identities at the bottom. That's not always the case. I don't see any squares here, so I can't use those now. They might come up later, but I can't use them now. So, blue line's bugging me. There we go. So what I need to do is use the green and yellow stuff up above. So I'm going to change everything into just sine and cosine. Let's see if that helps at all. Cosecant A, I can write as 1 over sine A. Well, cosine A is just cosine A, so I'm going to leave that. The idea is a lot of times you want to get it just into sine and cosine. Try to get rid of any cotangents, cosecants, secants, tangents, anything like that. And then this is multiplied by cotangent A. So cotangent A is this one, cosine of A over sine of A. Okay, so I can multiply these two things together. I'll just leave this first fraction alone, 1 over sine of A minus cosine A times cosine A is cosine squared A over sine A. And now I can add these two fractions together because they both have a common denominator, so I don't have to get a common denominator. That's kind of nice about this one. So this ends up being 1 minus, that's a pretty ugly cosine. Let's try that again. Cosine A over sine A. Whoops, I screwed up. You see where I messed up? Cosine squared A. And what is cosine squared A? Well, not just cosine squared A, but 1 minus cosine squared A. That is right here. Sine squared is 1 minus cosine squared. So this is just sine squared A over sine of A. And we talked about an example like this earlier. Basically, the top is sine of A times sine of A, so we're going to cancel out a sine of A on top and bottom. And this just becomes sine of A. And that's what we're looking for. That was what it was asking us to prove. Cool. Excuse me. All right. I lost track. Was that 8? Let's see. Zoom out here. Yeah, 8. All right, 2 left. 9 and 10. Let's look at number 9. This one says cosine squared x times, in parentheses, secant squared x minus 1. And that equals sine squared x. This one is screaming distribute me as well. So I already showed you one like that. Let me do it a different way. Because there is another way for your first step. If you distribute this, and that's the route you want to go, you'll still get the right answer. So if you want to do that, pause the video, try it, see if you can do all the steps. Actually, I tell you what, I want to show you 2 different methods. So we'll do the distributive way. We'll call that method number 1. And we'll do the non-distributive way. We'll do method number 2. I just want to show you that there's more than one way that you can get the correct proof to the end. All right, so I'm going to distribute first. We'll do cosine squared x times secant squared x minus cosine squared x. All right, so I distributed, and I'm going to change this secant squared x by using that highlighted pink Pythagorean identity, or reciprocal identity. So this cosine squared x stays the same, times secant is 1 over cosine, so this would be 1 over cosine squared x minus cosine squared x. And then we'll multiply these, so we get cosine squared x over cosine squared x minus cosine squared x. Well, cosine squared x over cosine squared x is just 1. So 1 minus cosine squared x. And I think we have that over here. That is sine squared x. So first proof, boom, it's done. So that's if you wanted to start by distributing. And that's a great way to do it. If you want to do it that way, awesome. There's nothing wrong with that method. So let's switch up colors so you can tell the difference. But what if I didn't distribute first? What if I said, hey, I noticed this green thing here is a Pythagorean identity. And where is that? That is right over here. Secant squared x minus 1 is tangent squared x. So I could have started out this way, cosine squared x times tangent squared x. And just simplify that stuff in the parentheses first. Totally different first step. We're getting, like, this looks way different than what we did over here in blue. Tangent squared x, I can write that. I'm going to use the top here. I'm going to use that thing. So this ends up being sine squared x over cosine squared x. Now, there might be a couple of questions here, like, how do you know not to use this one? Well, it's not really going to help me. It's just going to turn it to cotangent, which is not going to necessarily simply cancel out a cosine. Or you might say, well, how do you know not to just use one of these? We're just going backward. So that's why I chose to break it into sine and cosine. Well, if we multiply these, we get cosine squared x times sine squared x over cosine squared x. The cosine squareds cancel out, and we're left with sine squared x. Oops, there we go. I don't know why I put a box around that. I didn't need that. So this would be the end of our proof. We'll just put that little rectangle. I don't need this mark here either. Get rid of that. There we go. So once again, uh, depending on your first step, you might have a different looking answer than somebody else, and that's okay. So if you're looking at like an answer key to something and you say, oh man, I did it way differently than they did, as long as your steps are all correct, your proof is good. You don't have to worry about um, mimicking, your teacher if your teacher did it differently, or if maybe a classmate did it differently. Forgot an equal sign there. All right, last one, number 10. Let's get through this one and then we're all done. All right. So this one, you could maybe make the argument of working with either side. They could both maybe be turned into the other. But I think working with the left on this one might be just slightly more simple. So we've got 1 minus sine squared theta over 1 plus cotangent squared theta. And I am seeing some Pythagorean identities here. Let me get rid of this stuff to start fresh. 1 minus sine squared is right there. And 1 plus cotangent squared is right there. So I can just change these two right away. I can change them. 1 minus sine squared is cosine squared. Theta, not x this time. Over 1 plus cotangent squared is cosecant squared theta. All right, well, I want to get to sine squared theta times cosine squared theta. And if we know that cosecant is the reciprocal of sine, then our next step, and this is where I'm seeing that, cosecant is the reciprocal of sine, is just to say, well, if I've got cosecant squared theta on the bottom, if I bring it up to the top, that turns into sine squared theta. And that's exactly what we need. I guess technically we need one more step because they have them written backward. So, but since multiplication is commutative, you can just write them the other way. Sine squared theta times cosine squared theta, and that's what we're looking for. Sine squared theta, let's move over cosine squared theta. Boom. All right. So, just a half hour later, we got 10 proofs done. Not too bad. Hopefully this has helped you a little bit. Remember, just because you did a different first step doesn't mean that it's wrong. If you get to a dead end, maybe stop, cross out what you did, start again. But these trig identity proofs are not easy. Once you start getting the hang of it and you can see a couple steps ahead, it gets a lot easier. However, don't get discouraged. If you make a few mistakes, that is normal on this stuff.